Hello everyone, welcome to the study of the residue of f of z at the poles. So we let f of z to be defined everywhere except at a simple pole z is equal to alpha. We are letting our function of f of z, where z is a complex number, to be defined everywhere except at a simple pole which is z is equal to alpha. Then the residue of f of z at z is equal to alpha is given by this function. R of z is equal to bracket z minus alpha into bracket we multiplying by f of alpha, or it can be given by a residue which is equal to limit as z tends to alpha of f of z. I repeat, we are looking at the residue of f of z at the poles. So we are letting our f of z, where z is a complex number, to be defined everywhere except at a simple pole which is given by z is equal to alpha. Remember, a pole, it is a point where the function is not defined. So it is defined everywhere except at a point of a simple pole, z is equal to alpha. Then the residue of f of z at z is equal to alpha will be given by r of z is equal to z minus alpha f of z, or r of z is equal to limit as z tend to alpha of f of z. Now, to make this concept clear, let us have an example. Here you are given f of z is equal to f of z is equal to 2z divided by z plus I. Now the pole here, then at z is equal to -1 is a simple. This is a simple pole. It's a simple pole. It is very clear there. It can be seen. It is a simple pole. Now, to get the residue will be given by r at -I. It will be given by limit as z tends to I of z minus I, z minus I, z minus I of 2z divided by z plus I, which can be written as, this can be written as z minus I 2z divided by z plus I. Z plus I, which here we can make use of L'Hospital's rule. And when you make use of L'Hospital's rule, of course, it is going to simplify to -I2. After expanding here and applying L'Hospital's rule, we will obtain that result. Thanks so much for taking your time to study with me. For more such learning, kindly tune on to my YouTube channel so that we may keep on learning together.